For my computer science IA, I've created an electronic version of a board game called Busted. And the object of this game is to not lose all of your chips, or in other words, to be the last player with chips. During the process of making this IA, I've made a series of success criteria in order to make the electronic game as accurate and true to the original board game as possible. One of these, well, some of these success criteria is that the game will proceed as it would a normal board game, meaning that the rules of the game are adhered to and implemented correctly, that each function of the game works as intended, that chip numbers are correctly displayed and updated, that each player will have a turn and can play their turn as they normally would, that when a single player loses all of their chips, they're correctly announced as being busted, and that the last player with chips is announced as a winner. In order to proceed, it's important to note that it's important to know the rules of the game, which are as follows. So when it is your turn, you roll the dice via this roll button here, and you take the sum of your two dice numbers. So in this instance, it would be 9. If your sum is not a 2, 7, or 12, then the corresponding chip number will be taken from your player's chip count. So in this instance, since we're on player turn 1, the player turn chip number will lose 9 chips and will be placed on this counter of chips on 9. As you can see, the player 1 chip number counter is now at 16 and there are 9 chips on 9. It's important to note that if the number you roll has chips on it already, then you would still click on the number as usual. And the chips that were on the board, for instance in the chip counter, are now out of the game, meaning that no one gets them and they're no longer in play. In this instance, the player who clicks on the number with chips on it will have no chips deducted from their player chip number, and then their turn is over, and they would press the next turn button. It's also important to note that the 2, 7, and 12 numbers are highlighted as they have special functions in the game. The 2 and the 12 ensure if you roll a 2 or a 12, then you receive all of the chips on the board, and you can tell how many chips are on the board via this total chips on board counter in the top right corner. So for example, in this instance, if the player were to roll a 2 or a 12, then the player would gain 9 chips. The 7 is different from the 2 or the 12, as if the player rolls a 7, no matter how many chips are on 7, the player continues to place 7 chips on 7. Now we'll continue to play. Player 1 is already played as they've rolled a 9 and clicked on the number 9, therefore placing 9 chips onto the number 9. At this point, the player would click the next turn button, which ups the player turn to player 2. Player 2 would then click the roll button, and in this instance rolls a 2, meaning that they would click on the number 2, and they would gain 9 chips. You'll see now that the total chips on board is 0, and that the chips on 9 is also 0. The board is reset. Player 2 would then click on the next turn button to up the player turn to player turn number 3. Player 3 would then click the roll button, and in this instance, player 3 gets a 6. Player 3 would then click on the number 6, increasing the chips on 6 by 6, increasing the total chips on board to 6 chips. Because there are a maximum of 3 players on this game, the player turn will reset with the next turn button click. So we'll see the player turn counter resets to player turn 1. Player 1 would then roll the dice. In this instance, gets a 5. This process is repeated for each player until one of the players loses. So I'll continue to play the game. In this case, they have a 7. So 7 chips would be placed on 7 from player 2's chip count. Since player 3 rolled a 5 and there are already 5 chips on 5, player 3 will lose no chips in this instance, and these 5 chips that are on space number 5 will, in a sense, be discarded. You can see now that the chips on 5 reset to 0. Player 3 lost no chips, and there were 5 chips deducted from the total chips on board. In this instance, player 1 rolled an 8, meaning they only have 3 chips left. We see now that player 2 has rolled a 7, and that there are 7 chips on 7. You'll see that the number 7, or the amount of chips on 7, continues to increase, and there are 7 chips taken away from player 2. Player 3 rolled a 4. 4 chips are deducted from player 3's total chip count. And in this instance, we see that player 1 has rolled an 8, meaning that there are no chips deducted from his total chip number, as there are already 8 chips on space 8. Again, player 2 rolls a 7, and the amount of chips on 7 will increase by 7. Player 3 has also rolled a 7, and the amount of chips will increase again. Player 1 has become lucky and got a 6, meaning that no chips will be deducted. No chips will be deducted from player 2. And player 3 rolled a 6. This process continues until one of the players becomes busted, which happens in this instance. Since player 1 has rolled a 9 and they only have 3 chips left, player 1 is now busted as they are out of chips completely. You'll see that the player turn has automatically gone to player number 2, as player 1 is no longer in play. So player 2 will roll. Player 2 in this instance gets a 7. The game continues as usual. It's just player 1 cannot play anymore. You'll see that when I hit the next turn button, player turn increases by 1 to 3. We see now that player 3 has rolled an 8, and player 3 has become busted, meaning that player 2 wins. Busted is a game of luck, and it's very addictive once you know the rules of the game. Some more of my success criteria was that the game's interface would be easy to understand and see what's going on. And how I would implement this was by having a virtual board, that there must also be dice that players can roll, and that there are 3 different player chip counters, as well as a player turn counter. As you can see, I have these 3 chip counters down here, as well as the player turn counter up here, as well as a virtual board where players could tell what is going on. My final large success criteria is that my game would be bug-free, and I would review this by checking that the correct amount of chips are displayed and updated by the chip counter throughout the game, that each number is clickable and works as intended, and that all buttons on the game board are in fact clickable and work as intended. Um, Through extensive testing of my game with by myself, with friends, and with my advisor for my IA, I have yet to find a bug. In the future, should my client, or a random user be dissatisfied with my product, it would be very easy to edit, as Scratch allows users to easily modify products with the click of a button, as well as the fact that I've outlined the rules of the game in the instructions box here.